Hello everyone, welcome to the project presentation for the group TBA. This is how we merge the worlds. The group members are Mark Overholt and John Earls. So first let's talk a little bit about the problem that we are trying to solve. One of the components of iWisdom is the entity repository, which would store some of the data that has been brought up from the web. As you might remember in the lecture, one of the lectures where Dr. Chang talked about pulling data up from the web. That data you pull up needs to be saved somewhere. So somebody could manually write or come up with the structure to save the data into, but that could be cumbersome. So what we want to try and do is dynamically determine relationships between these entities in order to dynamically create the structure that the data could be saved in. So what we're trying to do is go from this collection of unsorted pages on the web, unstructured, unsorted, just a collection of pages on the web, go through all of the data and dynamically generate pairs of entities that are related to one another. And the way in which we're going to do that is the following. These are the two ends, and in the middle is the structure chasm that we are going to try and bridge with our program. So we're starting off with a bunch of web pages. In our case, so far we've used the Wikipedia files to seed our entity tagging. So we take a bunch of the entity pages and we parse the web pages. For each word or set of words, we create n-grams of multiple sizes, and we also store the relative location of each of those n-grams. For example, the very first word in the document would have the position of 1, and the next word would have the position of 2. As I mentioned earlier, we are getting our seed data from Wikipedia. Currently, we have 1,000 Wikipedia pages saved that we're running on. So after we've parsed our Wikipedia pages into this collection of n-grams, we need to tag the n-grams as data types. So for instance, the city Boston should be tagged as a city. The way in which we are doing that is by using a dictionary provided by Carnegie Mellon University, and it's called NEL. We use the dictionary from Carnegie Mellon to take each of the n-grams and convert it into an entity from this dictionary, and save the entity and their relative location. After having a list of all of the entities from a single page, what we will then do is build the hypothetical relations. What this is we're taking every entity from a page and combinatorially converting them into pairs. So every possible pair in the page will be computed. Even if it's the first word in the document and the last word in the document, that is a possible entity pair because those two entities may have some relationship in them. Once we have our list of possible entity pairs or relationships, we need to somehow figure out if those relationships are valid, if they're good or not. So then all that data is moved to the scoring functions. Currently, right now, we are scoring only on frequency and distance. Our assumptions are that if a pair of entities shows up in more than one web page, it is more likely that it is a real relationship, because if it shows up more often, more people are using those relationships, chances are they're valid relationships. Also, we're using the distance between the entities as a measurement. If the two words are fairly close together in a web page, that has a better chance of that relationship being true than if words were at the very beginning and at the very end. So having scored these relations, we get a better idea of which relations are better, or which relations are actually good. So some of our sample data that we've run, like I said earlier, we've been running on 1,000 unique Wikipedia pages. Some of our top results have been a city is related to a state or province, and that has shown up 1.4 million times. A city is related to a country, shown up nearly 800,000 times. And a city is related to a company, and that's shown up 493,000, almost 500,000 times. So seeing the fact that these relationships have appeared so many times over the course of these 1,000 documents, it leads us to believe that these are valid entity pairs. And just by looking at these three, we can tell that they are. But some of the other ones at the top of our scoring list, because they're appearing so many times, leads us to believe that they are valid entity relations. On the flip side, we can also rule out entity relationships by the lack of their appearance. For example, some of our lowest scoring relationships have been fungus and Olympics. That's appeared only once. And mountain range and office item has also appeared only once. So we get some pretty fun relations, or weird relations that don't exist. And we pretty much know they don't exist because the combination only appears once out of all of these pages. So that is currently where we are at in our project. Our basic scripts have been able to parse the pages and tag them, build the combinations of relations. The future work to finish up on this project is to improve the scoring functions. We need to count more things than just frequency and distance. So we're going to start using making our tagging a little better to filter out some of the more common words that show up and get tagged incorrectly. We're also going to start using some better calculations on distance and probability of whether or not those entities are listed to more refine our list of possible relations. But for right now, we have a pretty good start on developing the relations and seeing if they are valid or not. So I hope you've all enjoyed our presentation, and we look forward to reading your comments. Thank you very much.